Hello, we're going to be talking about some Kubernetes today. For a short amount of time, we'll be talking about Kubernetes. I'm kind of excited about this because at my company we have a lot of Kubernetes clusters. About 30 Kubernetes clusters. We've got them deployed across Amazon's availability zones in all the continents that they have to offer. And we have our a need to make sure that we've got them running optimally. So hey, how's it going, Quantified Quantum? Welcome on in. Happy to see you. Thank you so much for building our chat bot. I'm very excited that we have a legit chat bot. Oh, no stream notification today? Oh, well, I clicked the live button pretty fast. I clicked the live button pretty fast. So I've got a let's see here. So I've got the Zoom set up over here. Oh, we can even see there's some closed captions happening right there, and we've got some folks who are going to jump on the call with us to describe how. Oh, here I've got a website. I've got a website ready to go. Here we go. AI powered Kubernetes optimizations. I'm kind of curious about this. We have a pretty fixed amount of resources and limits that we set all of our deployments to. This is something that we haven't tuned a whole much other than manually. We've manually tuned it. We've changed some like the number of the cores, number of resources, the number of millicores, right? The segments of process that you can allocate to the how much CPU you want to give the application, and the amount of memory you want to give it. So we've got some questions. We have some questions. So we're going to have some folks who are experts jump on, and I'm kind of curious about to see what are they gonna talk to us about. I'm very curious. But I did send, you're talking about stream notification. I did send it to our Discord. I said there it goes. It's there. It just popped up. There it goes. Oh, before those people arrive, can you re-put the SSH host? Oh, the SSH host. Hey, how's it going, Mohammed? Welcome on in. Good to see you. We have 30 seconds, Quantified Quantum, the SSH host. That's right. I forgot about that. Well, do you want to re-put it? Maybe if we have, let's see if we can get it to it. Is this it? No, that's not it. It'll be around here somewhere. Where is it? Let's see if we can get to it. Let's see if we can get to it. Repositories before they jump in. Discord bot. All right, we got the Discord bot up here. Settings. We got the settings and our actions. Okay. SSH host. You said the SSH host. We can make that. So I've got that here. So we can edit the SSH host and re-put in the SSH host. I'm doing very good, Mohammed. Glad to see you here. Let's see here. So we've got, are they? Oh, they're already here. It's too late. All right, I gotta go. We gotta answer them. We'll have to put this up in a second. All right, 1 second. Admit. Okay, here we go. All right. Hey. How's it going, you guys?
Hey, Steve. Good morning. How are you?
Good morning. Very, very good. Happy to have you here.
Thank you, and thank you for having us. My name is Raji. I know we got introduced through Nicholas. I have my CEO joining now, Debo.
Hey, Stephen. How are you?
Hey, Debo. Nice to meet you.
Nice to meet you.
Likewise, Steph. And thanks for taking the time. I hope it's a great morning. You're both actually in Seattle, you and Debo.
Oh, wow.
Which part of Seattle are you in?
I'm south. I'm in South Seattle. I used to live in Bellevue and went to Bellevue High School many years ago.
Oh, nice. I live in Quina and our office is in Ballard.
Oh, there you go. All right, so we're not too far apart.
Yeah.
No.
Nice.
In the past, I stopped in Seattle, but I visited my uncle's at his college. He teaches in Yakima long time ago. And believe it or not, I went to the capital of apples in Wenatchee.
Wenatchee, yes.
So that's basically my experience in Washington State. So... we're here. Sorry, my one of my team members, my leadership, he had something for his daughter at school. So, but hopefully you connect with him sometime soon. Let's get started maybe with a round of introduction. Since maybe I'm speaking. I'll start with myself. I'm Raji. I work with Dabo and my boss Shani on some of the go-to-market initiatives and connect, some of the use cases to what we do in the heart of cost optimization on the Kubernetes side. Before that, I was in the financial sector for a long time, for 10 years, and that's where I learned the software business during my audit career. With that, I'll turn it to you guys and maybe a quick introduction and we'll get started. Thank you.
Nice.
I can go, Stephen, and then hand it to you as well. I'm Debo. I'm an infrastructure engineer. Started building DevZero, I guess, about 3 years ago at this point. We help businesses ultimately optimize their Kubernetes clusters, which ends up saving them money. Before this, I spent 6.5 years at Uber. I was responsible for a bunch of print projects.
In Uber, were you downtown San Francisco?
When I started Seattle, it didn't exist here. We had the ops office, but there was a little broom closet with it was very smelly with 4 people, and that's how engineering started in the city. Now it's, I think, 500 or 600 folks in downtown. So.
Wow. All right, there you go. Yeah, I remember. I remember the Uber offices before they were on Market Street, and they were getting started.
40. Yeah, it's a colorful interior, at least in the first office.
Nice. Yeah, it's good to meet you. My name's Stephen Blum, CTO, founder PubNub, and we've got a lot of Kubernetes clusters. Many Kubernetes clusters. Just kind of curious about. So we about 30 Kubernetes clusters that we operate independently that have lots of nodes in each of them. We manually tune based on the resource utilizations that we are expecting. And we've made a lot of optimizations over the years because we've been operating for a long time. So I'm kind of curious how you deal with multiple clusters, and each cluster is a little bit different because they're spread across Amazon's locations, across all of Amazon's regions. How much do you know about PubNub?
Less than you do. I'd love to learn a little bit about the business. Yeah.
So actually we could. We're a communication API, and we connect devices, mobile devices, and things. We started before Uber was started. We needed a way to. You've definitely heard of ride sharing and taxis. So Lyft was one of our early customers. Before push notifications were available on phones, we needed a way to communicate between devices, and multiplayer games were our first customers. Then we jumped into chat-based applications for more enterprise and customer support. And then telemedicine became more popular, so we powered that. IoT. So if you have any IoT devices in your home, you didn't know one of the hubs might be connecting up to us. You might never have known it. You didn't know. And so we've got over 1 billion connected devices now. With over trillions of transactions each month that power all these different use cases. And our Kubernetes clusters, they auto-scale up and down throughout the day. We're excited to see what we can do. Or actually, I'm kind of curious to see what DevZero has come up with over the years and what problems that we could learn from each other.
Yeah. I have actually read some of your posts, Stephen, before this, like when you were writing about Kubernetes, because I like to read up on people before getting on calls. So, correct me if I'm wrong. You have already looked at some of the spaces of the business level relationships that you can establish with the cloud provider, reserved instances, savings plans.
Yep.
And that aspect.
Mm-hmm.
So ultimately, our approach is I'll start with the zoomed out view, and then we'll slowly zoom in. We monitor 2 things: every single workload running inside of a cluster, and all of the other nuanced Kubernetes things like services, ingresses, stuff. And then nodes at what's happening inside each node, what availability zones they're sitting in, like the physical availability zones, traffic going between AZs and what type of compute's actually being provisioned underneath, etc. Based off of that, so we have one operator that powers all of this telemetry, collect everything in our control plane, which then starts to do math on figuring out what the right recommendations or what the right configuration should be for a given workload or a given node group, etc. at a certain point in time. Then, of course, there's people. Initially, during a POC, what we see is the platform engineer type person will go look at the recommendations, start manually applying them, but manual doesn't really work, except for example. Right after that, you end up installing our write operator, which then goes and keeps talking to our control plane and figuring out what recommendation needs to be applied where at what point in time. So we view every single cluster as each independent entity. They all have our agent operator, call it whatever, sending us data, receiving data from us, applying recommendations. And inside of our platform, we have this, it's all recommendations are driven by policies. And all policies, when they are evaluated in a very cluster local context. So the workloads in that cluster, the nodes in that cluster and whatnot. And that's how we end up doing optimizations. There's another operator which goes and takes care of nodes. Given your background, I'm sure you've heard of Carpenter.
Yeah.
We forked Carpenter a little while ago,
Okay.
and we just made it a little nicer. We've also invested. There are some of our customers, especially pharmaceutical companies and stuff that are running a lot of long-running jobs. Sometimes their jobs will take 30, 35 days to run. And in those cases, you can't really stop a job ever. So we have this thing called checkpoint restore, which uses Linux's CRY-U underneath to pause processes and move them between computers if needed.
Mm-hmm.
We have all of that stuff integrated into DevZ. It's called DZ Carp because we are very creative with our naming.
DZ car. Tell me more about that.
DZ Carp is our fork of Carpenter. That again communicates with our control plane and does a bunch of it tries to do things relevant to what workloads are running as well. So it's the
got it. Okay.
I'm
googling this as you're describing. I'm trying to see if I could get more details on it.
The source code is not public for that, unfortunately.
That makes sense. There you go. That's why I didn't show up.
We have documentation. That's it. Man. That's what we do.
Very nice. I'm kind of curious to see. So we've got a non-homogeneous workload across our cluster. We like to do co-location of containers that best fit onto Amazon's machine shapes that they give us because they give us certain machine sizes. Like you described, we have we pre-purchased compute with Amazon that gives us a dedicated savings. At that though, the challenge is of course that it's a fixed rate, right? And so even if we it's multi-year commitment, and then if you spend time to optimize you try to reduce your nodes through like I was thinking even with so this is what I'm curious to ask you a little bit more about, like even if we were to save today, like we wouldn't actually see any change in our costs because we've already pre-purchased the compute for years. I'm pretty sure this is a common challenge that you've run into, right? Am I on the right page? Does that make sense?
You are on the right page. Oftentimes, I know one company we work with was able to get out of their savings plan. Reserved instances are reserved instances, and we tend to respect them as much as possible.
Mm-hmm.
But the savings plan, what we see it's at the end of the day, it's a commitment to spend a certain amount of money in a certain scope every hour for an extended period of time is how it ends up manifesting itself.
Yeah.
We try to stay within those bounds, but like after optimizations and stuff, most of our customers get out of either they'll stop renewing it entirely.
Mm-hmm.
Which is what we suggest because my perspective is savings plans is only good for Amazon and their capacity planning and all that.
That makes sense. Let's talk more about the technology. I'm kind of curious because we've got in our infrastructure, right? We do a lot of vertical, or no, we don't, no vertical. We don't. That's the opposite. We don't do any vertical pod auto scaling at this point. And however, we are interested in implementing it, and we've actually enabled it within our clusters. We just need to take advantage of it at this point. But we do more horizontal, right? Obviously, that's the one that works the best, the horizontal auto scaling, and that goes up and down throughout the day.
Are you doing horizontal with Kata or just the default HPS?
The default, as far as I know. I don't think we're importing anything extra.
Okay. So that's good. There's another one called KEDA, KEDA, which is the Kubernetes event-driven autoscaler that we see many of our customers use. So for example, the data processing crew, they will always look at a Kafka queue size or whatever queue size, and based off of that, the replica counts start to get modified. We have customers that also use the default HPAs. You know what? Let me just share my screen. I'll walk you through the product.
Okay.
Stephen, please stop me, scream at me, shout,
yes,
whenever you want.
Sounds good.
This is top level queue.
All right.
Engineer clicks button.
Okay.
You select a flavor of Kubernetes, copy paste, run this. There's a Helm installer as well, but most people normally just get started with the default Kubernetes manifest. You install it in the cluster. Within about 60 to 90 seconds, a row will show up over here under the infrastructure column, which will have a cluster listed. For the sake of this conversation, I'll just pick this cluster. Stuff is pretty basic. You'll see, because we know where computers are running and what they kind of cost, we are able to understand what the cluster cost is, how much resources it's using, whether it's using GPUs, this, that, and the other. This is something we tend to look at. Like, of course, the first page I showed you, that's a very holistic view across your entire infrastructure, how are costs trending over time. So that's for someone such as yourself. Now, depending on how your platform engineering team is shaped, they might be focusing on individual clusters, groups of clusters, and whatnot. And for them, we have this departments component. We can get to that later. Let's go to workloads, because that's what you talked about, Stephen.
Okay.
Every workload, we understand what computers each of the pods are running on. Based off of that, we understand what they cost. We have realized on Amazon about 80, depending on the availability zone you're in, 87 to 88% of the instance cost is the CPU cores. RAM is pretty cheap, 12%. So we do math based off of that, and numbers show up. When you need to optimize an individual workload, I don't know. Let's pick one. Let's pick this one. So you can see stuff going on. Okay, this is currently running at about 35% utilization. So it's requesting 1.2 cores and it's using 0.42 cores, is essentially what it's saying. Mm-hmm. There's a bunch more graphs. So we track CPU, memory, network, and file system. And all of our recommendations are driven by that telemetry that we have. Optimization is what we care about. So I'm going to click on that button. This workload has a policy already attached to it, which means on a given that it's a scheduled and a non-detection policy, on a schedule, we are constantly going and evaluating what the requests need to be for this workload based on how it's performing, and we'll send down recommendations. So now your question was, I have an HPA already. How does life work in the DevZero land? Mm-hmm. For that, I'm going to jump into the policy section here and just go through the new policy workflow. What we do is we have this thing called an MPA. It's a multidimensional pod autoscaler. Traditionally in Kubernetes, you can only have an HPA or a VPA, usually not both.
I want both though. Why can't I have both?
Yes.
I want both.
And so, Stephen, the thing is, they actually started to work on a multidimensional pod autoscaler in 2019. Mm-hmm. But stuff in Kubernetes land usually goes a little slow. So they're still in conversation about it. Hopefully some code will get written at some point. But it hasn't been for 6 years, so we'll see. But we essentially took a lot of the discussions that they had, because they are learning from a lot of different companies and use cases, and we put it all together into our implementation. So you have an HPA already.
Mm-hmm.
Let's say there's a workload that has an HPA defined and you have still turned on horizontal scaling. In that case, our MPA will actually not make any horizontal scaling recommendations because we take the opinion that you have done something explicitly, you know more than we do.
Okay.
If you disconnect the HPA from a workload and set these things on, it'll go and start doing HPA type things. And of course, I'm sure your HPA probably is based on some of these metrics,
Yes.
or all of them in
Mm-hmm.
some capacity. So the replica portion of our MPA works in a very, very similar way.
So, quick question. We also have custom metrics that we go based on latency and
Yes.
other things. And is that possible to import that here, or is that not yet available?
We collect a lot of metrics already, Stephen. So custom metrics are Prometheus stuff already getting ingested. Normally, what we'll say is, whenever people have done that level of work, we will always be behind, realistically speaking. Yes, you could get Dev0 to look at that metric, but we'd say, just don't do this. Let's focus on the vertical aspect. So your horizontal scaling will continue as it is. We read your HPA settings. Based off of that, the VPA settings will actually get influenced.
Got it.
Because the HPA normally publishes events as like 50,000 things.
Right.
So there's that. This bit over here underneath, bin packing, the Kubernetes default schedulers are conservative. They'll only pack a computer to about 70-75% of request utilization. We have a scheduler plugin that goes and tries to nudge Kubernetes in a way so that the cheapest computers get filled up first, not just based on requests, but based on active utilization. This usually works well when it's paired with our workload optimization, because we are fixing requests anyway on those computers. So we try to pack computers as much as possible.
That makes sense. So wait, so you're aware of a multi-node group or multi, I guess, shaped node group style? How does that work? You said you targeted the lowest costs nodes that are available in the node group?
Yes. So your default scheduler, because you said node group over there, Stephen, are you using some sort of taints or node selectors to point workloads to certain node groups normally?
Yes. Yeah, we are. Mm-hmm.
So all of that will still stay the same, but inside of that node group, it'll always try to pick the cheapest computer. How it does that is, again, based on our telemetry. Let's click on you, my friend, and you. Go. Okay, so these are node groups.
Mm-hmm.
We have 3 in pre-prod. So let's say you have 2 of these and they happen to be, do I have any? Yeah, okay. So in this node group, we have 1 expensive computer and 1 cheap computer.
All right. Yeah.
The cheap computer would try to get that first.
Got it.
And so you try to free up the expensive computer as much as possible so that we can get rid of the expensive computer.
Ah, I don't know how much you can fit on a T3 small. I think we're gonna have some trouble getting some.
And so this is actually one of those, Stephen, where I'll go back to the policies page again, but now go to node policies, hit create. This is how you go and specify how nodes should be created. So you can get Dev0 to manage your node groups for you.
Oh, okay.
Which is the DZ carp thing.
Mm-hmm.
We are completely Carpenter compatible. If Carpenter's there, our workload automation just shows up, and we actually start making we haven't seen a single case where Carpenter has been configured correctly yet. Because a platform engineer normally, just as you said, every cluster is different, but infrastructure is code, and how people normally approach it, they tend to copy the same configuration everywhere. And a platform engineer will always try to fill in every single one of these boxes that Carpenter allows you to fill in, which is working against the system.
Got it.
And so our on Dev0, the reason why we have a fork is we tend to influence and change some of these values on the fly, depending on how the cluster is performing, what computers are cheap at a given time. We have actually been pretty successful at moving majority of workloads over to Spot for most of our customers, including because you have a checkpoint just on a bunch of this other engineering nonsense that Spot becomes more and more viable.
Definitely. What's I'm curious about the Spot. Let's talk about Spots real quick. So on Amazon and other providers, they have excess capacity that they want to sell it to cheap, right? If possible, they want to give you only as much as they have available, and then sell the expensive to those who buy the on demand, right? As much as possible. What with Spot, I know Amazon's got several options. You can get a Spot for a guaranteed like 6-hour window. Is there other kinds of, because I haven't been keeping up, but what is the current limitation for Spot instances on Amazon?
Default world that we see everywhere is you get a Spot instance. Depending on which region you are in, I think US West currently is running at about, Spot lifetime is about 8 hours and change. We collect all of this telemetry across all of our customers. Mm-hmm. We still get the 2-minute preemption disruption event that we react to and start provisioning new compute, moving workloads over there. So workloads never really have any downtime per se. We also tend to, the other reason why we go and keep changing the policies underneath is we are getting data about what type of computers are starting to be cheap in which regions. And so let's say USW EZ2, for whatever reason, is getting, like I4 instances are usually very cheap over the weekend for people that need a lot of network. Mm-hmm. They normally go to the C classes of instances, but the I's are cheap on the weekends for whatever reason in US West. So like computers are just going and calculating all of that and then changes policies underneath. Stuff works.
I can see where, I mean, you talked about I instances. I mean, those typically are for, they're storage optimized instances, right?
Mm-hmm. For people that have like Ceph and arbitrary things underneath who need a lot of like fat network pipes.
Got it. Yeah. So for us, like we do have some of those for our persistence layers, which are databases. The 2 minutes, if we're talking about 2 minutes, that's nowhere near, because we're talking about like petabytes worth of data. You can't copy that much in the data. It's gonna take a little more than 2 minutes. So I think that might be a challenge.
And I'm assuming you have PVs and stuff as well, running the DBs.
Persistent volumes, yes.
Volumes, mm-hmm. Yeah. So normally the other thing we also do is PVs get handled pretty neatly, generally speaking. The main impact that ends up happening for many stateful sets is the boot up time for a pod. So when the process is starting up, how much stuff it needs in memory. So those are the areas where people will start to use checkpoint restore, where you just pause the process and run it on a different computer. So it doesn't have to like boot up anymore. It just saves RAM, like fancy words. So combination of things, one size does not fit all. Will we be able to optimize everything? As an engineer, the answer is probably no. But most things, like generally speaking, what we have seen so far, a 30 to 40% reduction in actual like dollars out a month is what we traditionally see. There have been cases where we have gone 75, 80%. For the GPU heavy crowd, we have also seen 87%.
I'm very curious to see what the GPU Spot instance market looks like.
US West is always super cheap.
Really?
We, even for normal CPU workloads, we'll very often introduce GPU computers in that.
No way! Are you serious? Mm-hmm. So wait, there's all this unused GPU capacity sitting there available right now at this very second in Amazon West, and it's so cheap that even for regular...
It's cheaper than CPU instances.
What?
Same in Sao Paulo, actually.
Wow.
SE East one. Yeah.
That's amazing. That's interesting to know. Thank you. That's good detail.
Yeah, we just collect data from everywhere under the sun. So yeah, that's how we figure. Like, okay, the world is kind of weird.
Nice. Yeah, I remember probably 6 or 7 years ago, Amazon made available an API to look at their spot marketplace and prices over time in each of
We
their
track it every
zones.
minute.
We used to heavily look at that too, just to see what options were at our fingertips back then. We did have some spot fleets. What's interesting is that you're inspiring me. We should use more spot instances. What we should be doing. We're for
I think a combination of spot and OD in every single node group and actually going over provisioned if need be is a strategy that works pretty well. We have also seen cases where customers have now provisioned more capacity, but their ultimate costs have gone down because of the introduction of Spot. So the replica counts went up a bunch for many workloads. There's trickery you can do on all sides.
nice. That's interesting. I like that. All
Do
right.
you have a big savings plan commitment today
Yeah.
for many years?
And we've had really good experience with Amazon and their team. They're fantastic. They've done a lot
Good
of great,
guys.
and yeah, love working with them. And yeah, we have the commitments with them and things like that to get us the best discounts. Which
Yeah.
the hold off, so like we can. So here's the idea: it's like we could either spend time optimizing costs, or if we could just prepay up front with the big check, then we can, instead of spending time on optimizing, we could spend time on innovating.
Yeah.
That was like our rationale. We got close to the level of savings that we'd possibly get if we were to spend many hours, months, quarters trying to optimize.
Yep.
Instead, you're just like, okay, let's pay up front and we're good to go now. There you go.
Yep.
No, that makes complete sense. Okay.
So with that, Steph, I wanted to show you some slides. But because you asked some of the technology, we went ahead and we talked about the technology, which is great. You got to see, what's inside under the hood. But if you see, do you see my screen here?
Yeah, it looks good.
Yeah, good. So this is a real use case from two clusters customer that we actually helped saving them annually on the two clusters 776,000. They had some GPU. I know you mentioned some GPU a little bit here, if you see, but mostly are CPU and memory. So, and now they're actually beyond the two clusters. Of course, they're adding more clusters. Same scenario here, a little bit different. This is, I think, without GPU, but this is 321,000 annual savings. They're 90% underutilization, which is crazy, a lot of waste. So that's basically in terms of some of the results as what's going on under the hood.
Yeah.
Yeah. So I was hoping actually maybe if possible to benchmark what you have against what we can provide if you want to test on a cluster or something, and it's totally like in your ballpark of how to run things. I don't know how big is your team, by the way.
It's we've got quite a bit. I mean, it's you could see details on LinkedIn to kind of get a
Yeah.
picture. And that's pretty up to date, though. I think it's not like a full
Hmm.
picture. And yeah, we're engineering heavy. We'll put it at that.
Yes. Yes. Yeah, because uh, my daughter was asking me, "Hey, do you have any work tomorrow?" I said, "Yes, of course. I have a meeting with Popno." And she says, "Like, what's Popno?" And it goes like, "Yeah, it's like you when you play on your Nintendo Switch. If you have to send instant message to your friend, they carry the message, they deliver it there."
Yeah.
So it's you know, I would imagine there is a lot of traffic on the infrastructure. So
Yes.
how best basically we can help, if any, opportunity in here for us to collaborate maybe on just benchmark a use case and see what you can get of if you have some of the maybe assign team member to us, and like best way to collaborate.
Yeah, thinking about next steps would be great to get armed with things that can make me your champion. So, for example, like charts and graphs and the big money savings. And hey, if we were using spot instances better, those sort of things. Or because our team they have been looking at Carpenter and some other
Hmm.
alternatives. Like I was saying, it's not as high on the priority list because we've prepaid, and
Hmm.
we're looking good on the numbers that we like.
Hmm.
Though, yeah. So I think that would be a good next step. Send me the weapons. Send me the PDFs and presentations.
Yes. I will. Well, I'll send you this presentation. Of course, I'll send you a use case as well that we have published as well. Is anything that we can, support you in the meantime beside these assets?
I think that's great. Any other? I mean, I can't ask for more. You've already given me some great advice and some information. That sounds really exciting. Oh, we also run a lot of ARM processor workloads, so a lot of ARM. Uh,
Gravitons. Yeah.
Yep, there you go. The gravitons. The
Hmm.
Amazons have got which are great. Like this performance on those, they're amazing. Especially with what was it the Spectre bugs on those
Mhm.
processors. They had to block off a lot of the accelerated power that you get in the early branching, which reduced the capability of those older CPUs quite a lot. And so then we moved over to Graviton. It was like a whole new world where it's like we gained 10 years back in all compute power. So it was amazing.
Yep. Yep. And
Stephen,
just
I just dropped a note. I'll couple minutes late. Great meeting you. I'm sure we'll chat soon.
yeah, Dabo. No worries. I'll pick up and continue with Steph. Thank you. Yes, Steph. So that's what we do in a nutshell. And again, sometimes things happening with engineering teams are busy. I just want to highlight very thing that is important because we know that the time is valuable for team members. We made the solution as seamless as possible to connect to and onboard things. It takes less than a minute. It's about 45 minutes where we did the install the existing Kubernetes cluster and connect that through the read-only operator. Wait for a couple like few days, start analyzing all this data. We meet for another 20 minutes, 25 minutes, and then we'll leave it for another few days, and then we start optimization, and that's basically another like 25 minutes. All in all, it's less than 2 hours in across the 10 days. I mean, like even an hour, less than an
Yeah.
hour. All the POC or POV involvement, and it's pretty easy to set up.
Nice. Yeah, that's great to hear. We could definitely achieve that goal. The challenge from a timing perspective isn't necessarily the installation period. It's the compliances that we got to deal with. We got to do the paperwork first, and that
Yeah,
part takes a little
yeah,
while. It takes a
and and,
smidgen
and
extra.
it's good to start this compliances. Is that more of a we are SOC 2 by default if that's security things, but also we have some security documents. What when we said the compliances, what other thing that is important to you besides the security? Of course, I would imagine.
Yeah, pretty much exactly. Yeah, I think we're on the same page.
Yeah. Okay. Cool. So is it? I'm here to work with you and make it as easy as possible. And I really appreciate the opportunity from Nicholas to you to connect us both. I think we have some great synergy, some value to provide despite the saving plan that you have. Let's try and see where we can carry forward and save you extra money if possible. You know, but we can talk like for until when all week this week, but once you try it, is it's I want I love to give you the feeling of the tool. Let's put it this way. You know.
Absolutely, yeah. It's from just to set expectation. Probably take a little while to get everything
Mm-hmm.
going on our side. Also, we've got things set up for a while. Like like I was describing, we've prepaid, for a long time. So
Mm-hmm.
this from a timeline perspective, I
Yes.
can't promise anything soon.
Hmm. Yeah, sure. We're here to work with you. No, not we're not, like pushing for anything. But if down the road you see the value, let's connect. So maybe when should we come back? Is it like next quarter, next year? Uh, where do you see things visible?
Send over any materials that make sense to share with the team, and then we can figure out from there. I think that's a good next
Okay.
step.
Sounds good. Sounds good. And thanks for all you do on these podcasts. I'm jealous of the Shure microphone. I love the sound, how
Oh
it
yeah,
sounds. So it's pretty convenient. I might have a setup myself soon.
nice. Yeah,
These calls.
that's really it's really great to hear. I mean, because we're for the I don't know about you work remote too from home, and
Yes, I work remote. Yes,
isn't it
I am.
wonderful?
Yeah, yeah. I am actually here in San Francisco, particularly in San Mateo,
Hmm?
close to the airport, SFO. So anytime you're coming back to visit the city, please don't be a stranger. I'll make sure my cell phone is my signature. We can grab coffee, lunch. It's my treat. Be my guest, please, anytime.
Yeah, thank you for the offer. I tend
Of course,
to
sir. Of course. My
nice. Yeah,
pleasure. Right on. Any question before we
good to go.
good to go? All righty. Sounds good. You have a great rest of the day, boss. Thank you so much.
You too. Thank you.
Yeah. Talk to you. I'll send these over and we'll go from there. Thank you.
Sounds
Bye
good. Bye bye.
bye. Bye. Bye.
All right, we got it. We did it. We figured it out. We got some Kubernetes optimizations conversations happening there. I was actually pretty excited about it because there's a lot of neat things. Did you guys know about that 2-minute warning from I didn't know about a 2-minute warning. Thanks for the likes, you guys. So we'll probably head out here in a sec. Then I've got some other meetings that we can't broadcast. Only certain meetings we can broadcast. I think that would be neat to be able to broadcast more meetings, but I want to be very careful because we've got a lot of things to consider. So it was great to spend time on this. Oh, by the way, if you were here yesterday, we figured out how to get a very strange bash and ZSH all at the same time is required. I've never needed to do this before. I don't know if you figured this out, but it's a neat thing. So Coproc is available only in ZSH. And time, and thank you for the likes, you guys. And time is available as a binary that's available only when you use bash. So otherwise, if you're in ZSH, you can do which time, right? It's not a thing. It's a reserved word. It's something special. Evening, a beauty. Good to see you. Welcome on in. Happy to see you. We just got off a call with some Kubernetes optimizations teams. They were helping us understand a little bit more details, and we described what our current infrastructure looks like. And you know what? We learned a few things. I forgot about. Did you know? This is actually very strange. I didn't know. However, it's very strange that Amazon has GPU instances that are cheaper than some of their CPU instances because of the spot marketplace price. People, they don't know who. We're all like clamoring for all these GPU instances, but they're sitting over there in some of Amazon's data centers just being unused right now. And so they are very low cost. It's amazing. Who would ever thought? I never even think that. But it's good to know if you were looking for some compute and you didn't have a pre-purchase, you could use Amazon to just lease maybe even a spot instance. Thank you for the likes, you guys. Lease a spot instance even with a GPU and it'd be super cheap. Who would ever thought? I didn't know that. I thought that was amazing. I didn't even think about that. That's crazy. But even that super weird but very useful to know. I know, right? Cosmere. Wait, how do you say your name? Cosmere Descent Technology. Is it Cosmo Irradiance? Is that Irradiance? Cosmo Irradiance? Cosmo. There we go, Cosmo. Well, that's Kaya Cosmo. I know it's super strange because it's really expensive compute. Like the GPUs are expensive. They're very expensive. I just can't. I'm surprised that you're gonna get super cheap compute even if you don't use the GPUs, it's still cheaper, isn't it? Isn't that really amazing? I thought that was super unexpected. But yeah, so we were able to get our tool working here, which was very, very interesting. A combination of Bash and ZSH. First time ever in my entire life that I ever had to do such a thing. But we got it working. Oh, you're new? All right, Shy? Was it Shy? Am I saying it right? Shy? Welcome in, Shy. Good to see ya. Well, we were talking about Kubernetes just a little bit ago, and our infrastructure, our scaling, different regions, and things like that. So thank you for all the likes, you guys. Appreciate it. We've got a lot of technology. Maybe we could go over. I don't know if you have any ideas on what future stream contents we can do. Let me know. What topics are you interested in? Let me know. Oh, Torva. So the product automatically moves workloads to cheaper machines based on demand using AI to analyze the load and decides when to scale or shift resources. Right? You got it. Torva, you got it. Which is pretty great, right? It sounds actually pretty interesting. All right, so Cosmo database engines. Ooh, database engines. So database engines are neat because you got different shapes and sizes, right? So you've got the log-based time series databases, and then you've also got the traditional databases that are schema. They have schemas. And they have data needs to be assigned based on their locality in each row. And then you've also got columnar stores where it stores each of the data elements in a separate file, which is kind of neat. I just built a multimodal one. It's a great project. Did you, Cosmo? Wait, you did? A multimodal one? Wait, hold on. Wait. Are you talking about a database engine multimodal? Tell me more. Wait, Cosmo, what are you talking about? You tell me more about your multimodal database project. I'm actually super curious because existing databases, right? You've got Mongo, you've got Cassandra, you've got like Postgres, right? Relational database, MySQL. Then you've got like memory-oriented databases, which are typically only in memory, like Redis and Memcache. And then you've got like search databases that are full text. They're intended for searching, which is like Lucene or Elastic, right? You've got Elastic. So there's different shapes of databases that exists. They each have their own intended purpose and what you want to use them for based on your use case. So it's kind of interesting. And if you're talking about a multimodal database engine, what are you doing? I'm actually kind of super curious. If you can say, it's okay if you can't say. It's okay if you can't say. But well, I do. Let me check my time. I think I gotta go here. I've got another meeting showing up, and then I will. Yep. All right. So I do got to get going. But I'll be back later this afternoon, and we will go over. I think we're gonna resume our Rust blockchain. I think we're gonna resume our Rust blockchain project. 20 minutes. I know, Torva, you're always 20 minutes. It's always got 20 minutes. So I have like about 5 minutes left, and then I got to get going to get ready for the next meeting. So got about 5 minutes left, and then I've got some other things to take care of. But what else? Can we look at? So yesterday we made some updates to our MCP server that made some improvements, and now we can measure them directly, so we can even see how fast it is. So you can see we've got a very fast MCP server that boots very quickly. Like 158 milliseconds. That's pretty good. That's really good, especially for a Node.js application and one that uses node modules, which can get pretty heavy after a while. Our node modules look pretty good. So if you look at our node modules, disk usage -h, and you go node modules, you can see that it's 50 megabytes, which is that still sounds like a lot of JavaScript. 50 megabytes of JavaScript, just the code alone. 50 megabytes is a lot. The good news is that not all of it's used. So you see, we've got this. We've got some dev resources here. So a large bunch of it I'm actually kind of curious. Let's see if we can. Let's do this. Let me grab just this right here. Right here. I got it. Let's do. We only want to open it. Oh, essentially, it's a database that relies off of in-memory adjacency lists to speed up query time and allow for different data types to be stored more optimally. That makes sense. It does make sense. It does. So I'm actually kind of curious, Cosmo. So did you write your own? Is it all your own? Did you build it yourself? Because You can write your own indexing schemes, your own indexing engines. It's really easy to write indexing for different kinds of, it's all, you're from scratch? Nice! So you're very familiar with different data structures and types that you could use to represent good, fast searching capabilities. AB, 30,000 lines right now. About 30,000 lines. That's nice. That's really awesome. Virat Kohli birthday. Wait, someone's birthday? Happy birthday. Thank you for saying in this chat. So many birthdays. Oh, there you go. Virat's birthday. All right. Sounds good to me. About 30,000 lines of code. That's pretty impressive. Oh, Cosmo, what'd you write in? Is it Java? I have a feeling it's Java because that kind of seems like it's probably, or is it Golang? It would be great if it was Golang. If it was Rust. Oh, your God is Rust. You said the right word. You said the right word, Cosmo. You said the right word. Rust is the best option, especially for a database, right? Oh, you're doing it right. That's great. Cosmo, good job. Fantastic. All right. So are you using any asynchronous engines, Tokyo or anything like that? Rust. You said Rust. You said it right, Cosmo. You're doing it right. All right. So you're building something legitimate here. You're building something intended for, critical systems, right? Rust is built for critical systems. I'm from India. All right. But Busted Gamer, welcome on in. Happy to see you here. We're talking a little bit about Rust. So before we get to Rust, I'm actually kind of curious. Let's do disk usage -h on this directory. All right, so that's about 7 megs right there that we know. New subscriber, cool, that's great. Thank you for subscribing. Appreciate it, Busted Gamer. Appreciate it. Agreed. Yeah, Tokyo Async. I was about to say Tokyo Async. Also, on wall for write-ahead log. Memtable. Rust also allows for memtable and write-ahead log. Sharding, so we can have over 1.8 million writes a second with write-ahead log. There you go. You're doing it the right way. That's so great. You're doing it right. So you use the write-ahead log as a time series stream of transactions, essentially. And then you can go through and have an asynchronous process, probably through Tokyo and another thread, that can go through and read and then store the data in the right format and index it, maybe even another thread. So you can index the data in another thread. There you go. I know Rust is used for fast execution. You got it, Sid. It is. We got Cosmo in here who's building some legitimate technology with Rust, creating a database using the industry, pretty much the state-of-the-art industry approaches to writing scalable and fast databases. So you can do 1.8 million writes per second, which is phenomenal, right, with your write-ahead log. And then you can jump into starting to store the data into the shape that you're interested in, and also based on the indexes that you want, right? Is it going to be a stream index? Are you going to do a full text search index? I don't know if you have that. You might not have a full text search index, but you probably have things like string matches, at least, maybe an index of a string, or maybe something along those lines. You might also have numerical indexes and sorting, because you need to be able to sort and things like that. Why you do play some games in live? Oh, we could maybe someday. I'm mostly focused on software engineering. We're mostly software engineering, and we want to get back to our crypto coin. So we've got Vi SRC. So you can see here, so you got some Rust here on the screen. We'll probably start this up here again later this afternoon. Maybe later this afternoon we'll jump back into Rust and get our blockchain. We're doing some blockchain technology. We're writing it all from scratch, all in Rust. Of course, we're using libraries like Tokyo, right? Using some Tokyo in here. And thank you for the likes, you guys. And then we're also using SQLite, talking about databases. We're using SQLite for the ledger itself. You're studying artificial intelligence. Oh, nice! Engineering in Tamiluandu. Okay, you're doing it right. Artificial intelligence is the right thing to be studying these days. It is. It's absolutely the right thing to be studying because it's the future. It's the future taking over everything. Thank you for all the likes, you guys. I'm really excited to be back later today. Do got to get going though. I want to get more. Also, we're doing Lua. We've got Lua as our smart contract scripting language. TQ, bro. All right. TQ sounds good to me. So thank you everyone for joining. We'll be back a little bit later today, probably, maybe. We'll see how it goes, and we'll continue our Rust adventures, building our blockchain with Rust. All right, we're headed out here. Thank you for all likes and for hanging out today, even for the Zoom chat. We'll be back a little bit later today. We actually separated the storage from the index layer. There you go. You did it right, Cosmo. You're doing it right. You're going to keep a separate index and storage. You got it. Whilst storing the docs graph text, etc., you can just do one query. That's amazing. That's so good. Always been a pleasure, Torva. Thank you for spending time and moderating as well. Thank you, Torva. We'll be back. Oh, Torva, saw your message on Discord. You got upgraded to moderator on Discord. We have a dedicated moderator channel in Discord. You are now in it. You got added. But yeah, thanks so much for that, sir. Absolutely. Cosmo, you're doing it right. You're doing it right. I'm excited. Cool. All right, we'll be back. Oh, do you know any near Wi-Fi password coding? Wait, what do you mean? Oh, what? Blessed Gamer, what? Do you know near Wi-Fi password coding in Python? What are you talking about? Do you have C++ courses? Oh, no, we do not have C++ courses. I asked her, we do not have any C++ courses. I asked her, Rust, though, we do. We have some Rust. So if you want on our YouTube channel, you could see some Rust. We've got quite a bit. And maybe also some AI. We got some AI in there too. And in the future, also some more Python. We'll be doing some more Python as well. So thank you everyone for joining. I'm headed out now. I'm clicking the stop stream button. We'll be back. All right. See you everyone. Bye everyone.